All right, so last time we had taken a look at some different set operations inside of this idea of sets, working with some Venn diagrams. We're just going to rehash a little bit of what we did to remind you where we were. We talked about set intersections, things that they have in common. Unions is the joining of two sets completely inside of one sort of commonality. We talked about that being the idea of a union of a marriage. Yes?
Oh, okay. Sorry, but I don't remember. Why is there a 1 behind the X? Or is that just a line?
It's a line. When we read it as the phrase such that. So like when we're reading, I'll just read one of them, but when we're reading this is read all X such that X is an element of A and X is not an element of B.
Okay.
So this line simply means such that.
Okay.
And then we did the relative complement or difference on the bottom, which is to take everything inside of one set and then omit a portion of it that's sort of contained in another set already. So we had looked at those last time. We did some examples. We also talked about the fact that this idea of unions and intersections is commutative. It means you can do it in either order. We did some associativity and distribution properties as well. We encountered the cardinal number formula, and we talked about the fact that when we count these items inside of set A and inside of set B, we double count the overlap in the middle, so we have to subtract it out one time in order to take care of that overlap. And we did the Cartesian product, which was ordered pair kind of groupings from two different sets. So we had done that, and I think that brings us up to current, right? Mm-hmm. Okay. So what we're going to do next in these diagrams is that what we're going to do next is we're going to create diagrams based on some set properties. In particular, some of the set properties that we looked at last time. So the first one we're going to do is we're going to do A complement union B complement. Now let me start out by telling you there's several ways to do what I'm about to show you. And on this particular one, it's not very challenging. There's a lot of things that you could look at and say you can probably just figure it out without even having to do what I'm going to show you. You can reason through it. However, they get much more complicated much more quickly when you have more than two sets. So what I'm about to show you is going to work very well for more sets at once. So this is the method I'd like for you to use because it will work in general for all of the ones we're working on. Okay? So to start with, there are two sets. So what we're going to do is we're going to draw a Venn diagram. And our Venn diagram is going to have two circles. One circle for set A and one circle for set B. And we've got the universal set on the outside. And what we're going to do is we're going to label the different regions with numbers. Okay? So I tend to go with 1 here, 2 in the middle, 3 here, and 4 on the outside. There's nothing special about that. You can put your numbers wherever you'd like, but you're going to have 4 of them because there's 4 distinctly different regions that this splits our diagram into. So far, so good? Okay. What we're going to do next is we're going to actually write out what these sets are in terms of the numbers that we've just assigned to the regions. So if you look at A with the bar on the top, what's that mean? Complement. What is A complement asking you to do? Everything not in A. So which of those numbers are not in circle A? 3 and 4, right? We're going to do the same thing with B complement. B complement, which of those numbers are not in circle B? 1 and 4. And what we're going to do now is we're going to join all of this together with a union. What does union mean? Yeah, join it all together. You get everything. So which numbers are going to be in the union?
1, 3, and 4.
1, 3, and 4. So what we've very much done is we've done the work, the show the work part of the problem. We haven't done the answer yet because the question actually asked us to do what? Shade the diagram, right? We drew the diagram, but we haven't shaded it. So we're going to go back over here to our diagram and we're going to shade the regions that say 1, 3, and 4. So if you have highlighters, you're welcome to use them. You can just shade in with your pencils. That's fine too. You guys are ed majors. You might even have some crayons or colored pencils. So whatever you'd like. You're going to shade in all 3 of those regions. So everything except for 2 is shaded in. And this is the answer to the question. Okay. So far, so good? Okay, that was an easy one because there's only 2 different sets. The next one's going to have 3. So the next one we're going to do is A intersect B union C. No complements this time, just all of the original sets. But there are 3 of them, yes? Now I actually haven't drawn you a diagram with 3 sets in it yet, so this is a first. It actually ends up looking at least partially like the Olympic rings, but just with 3 circles instead of 5. So we've got A, B, and I usually put C on bottom. Again, that's just where I put them. You can put them wherever you'd like. But they do have to overlap so that they each overlap each other in this way. Okay? Those are the maximum overlaps possible. There are more than 4 regions, yes? Yeah. So we're going to have more than 4 numbers as we list this out. What I do is I list across the top. So I usually just list straight through circles A and B like I already did, 1, 2, and 3. And then I list the overlapping region in here. This one is the bottom and then on the outside. If you choose not to list yours in that order, that's fine. Your shading will still match mine, but your shading and your numbers better match what is on your paper to each other. Okay? So your answer will look the same. Your work for your answer will look slightly different. So this is 1, 2, 3, 4, 5, 6, 7, and 8. Okay, look good so far? All right, so one of the things that you remember from long ago, I suspect, is what do you know about parentheses when you're working in a problem? That's what you do first. So we're going to do the same thing here. So we're going to start inside the set of parentheses with set A. So we're going to list all of the numbers now that are actually in set A. So somebody help me out. What numbers do you see inside of set A?
1, 2, 5, 4.
1, 2, 5, and 4. In any order, that will work. The other thing inside that set of parentheses is set B, right? So what numbers do you see inside of set B?
3, 2, 5, 6.
All right, 3, 2, 5, and 6. Now, this is sort of like putting a line underneath it when you do addition and subtraction. We found the individual pieces, and now we're going to join them with what operation?
With C.
Yeah, intersection. We got to do inside. We haven't done inside the parentheses yet. We haven't actually joined these two. Yeah, you're ahead of me just a little bit. So we'll get to the union with C in a minute, Michaela. Yeah, but right now we're still inside here. So we need the intersection of these two, right? What does intersection mean?
Together. Or no, they all have to have one. No, I don't know.
Kayla? What they have in common. Kayla had it right. Yeah, so what they have in common, right? Like the street intersection, right? We call the intersection the part where they actually cross, where they meet in common. So what do they have in common? What do you see?
2 and 5.
All right, so they both got a 2, and they both got a 5. So the answer so far is we're looking at the regions 2 and 5. Now we've done everything inside the set of parentheses, so we're ready to move outside, which is the C part. So we need to have the other set C listed. So what number regions are inside of set C?
5, 4, 7, 6.
4, 5, 7, and 6, or 6 and 7, yeah. Okay, so these are the two sets now that we're comparing. The set that has regions 2 and 5 with the set that has regions 4, 5, 7, and 6. And we're going to join them.
And union, so
With
they're
the-
all together.
Man, Michaela, you are on top of it today. You betcha. All right, so we're going to join them with the union, which means that they all have combined together. Exactly. So there's a 2 and a 4. 5 is listed in both of them, but I just write it down once. There's no reason to duplicate the writing it down part. And then I have 6 and 7. So these are the 5 regions that are referenced. And then what do I do for my next step? I shade those 5 regions. So I'm supposed to shade region 2, 4, 5, 6, and 7.
Question.
Yes?
So on the first one,
Mm-hmm.
why did we do like the numbers that weren't in it, but on C we did the numbers that were?
Does anyone have an answer for Whitley?
Complement.
Yeah, it's that bar that's on
Oh.
top. That's what tells us. So when there's a bar on top, it means the thing's not in the set. If the bar's not there, it means it's the things that are in that set. Yep, good question. Any other question on these two? Okay, I have one more. Like this anyway. All right, same directions, but we're going to do A intersect B complement, intersect C complement. All right, so the same picture, basic picture is going to be drawn with 3 circles labeled A, B, and C. And there's our universal set. And we have our numbered regions, and we'll number them the same that I did before. What are we going to start with? Yes,
Do
Tristan?
we have to put it in a box, or can we just make the circles?
It's a good question. What do you guys think?
Yes.
Why do we need a box? Yeah, it would depend on what's going on with number 8. So they all are going to reside inside of that universal set, Tristan, because the universal set is the big overarching description that applies to all the sets that are inside. And potentially some things that are even not inside A, B, and C. So yes, we do need a rectangle. I'm glad you asked that. Okay, where am I going to start? Yeah, inside the parentheses and with set A. You guys got it. All right, so what is set A? What regions does it contain? 1, 2, not 3, but 4 and 5. Yeah. What else do I need?
Not B.
Yeah, B complement or not B. You will hear it said as not B sometimes too. So what are the things that are not in B? 1, 4, 7, and 8. Did you guys agree, Kayla? Does that look okay? All right, now what am I going to do? Yeah, I need to do the intersection of these two. Not addition, it's an intersection. What does intersection mean?
The ones that are the same.
The ones they have in common, that they have the same. What numbers do they have the same?
1 and 4.
1 and 4. So right now I've got 1 and 4. Now what?
Now we're going to do not C.
Not C or C complement. Yeah, so what items, someone who's not talking to me today from the back, you guys are awfully quiet toward the back. What's going on with not C? Things that are not in C.
1, 2, 3.
Okay, good. 1, 2, 3, and
8.
8. Yeah, don't forget 8. Now what?
Now we
Another intersection. Put it all together. You got it. So this is A intersect B complement, and then intersect C complement. This is an intersection, so it's
1.
just the number 1, what they have in common. So the shading for this one's pretty clean, right? Just out here.
So, never mind. I don't know how to word that.
Are you sure, Allie?
Well, when would it just be 5? Would it ever just be 5?
It could be 5.
Okay.
Yeah, you want me to tell you when it's exactly going to be 5?
Yes.
When it's some version of this.
Okay.
That's actually 5. It's where they all 3 intersect.
Okay.
Yeah.
For the purposes of this class, will we have to do any, like, of the diagrams with more than 3?
No, ours are only going to have 3 circles. Yeah. And although, while I've drawn them overlapping, and you can always draw them overlapping, there's nothing special about the circles overlapping. I believe in some of your homework, you've actually got some problems where circles don't overlap. So like, let's say, for instance, that you started with a picture, and your picture has 1 circle here and 1 circle here, and you have an overlapping like this. So 2 of them overlap, but not the 3rd. That's fine. You can just put the numbers in the regions you do have. The process still works the same way. You just don't end up with as many numbers to deal with. Are you guys with me?
Yeah.
So it's actually an easier problem than we've been dealing with more. We've been dealing more with the general case, and some of the cases in your book gives you are more specific and are actually easier to work with. Okay?
So when would it be like that, where it was just?
They start with a picture given to you like that.
Oh, so
Yeah.
we're not gonna have to like draw.
If you're told to draw it from scratch, you're going to draw the general picture that I've been drawing with the 3 overlapping circles. But there are problems that your book gives you where they draw the picture already. Yeah, the picture's already there. So if the picture's already there, oh. If the picture is already there, you can just use the simplified picture that they have. You don't need to make the generalized, more complicated picture. Does that make sense? Okay. So I think that's going to come up in your group work. It's either your group work or your homework where you're going to have that happen. All right, so we're going to do a Venn diagram now that's got some details. So what we've been doing so far is we've been shading in Venn diagrams with sort of just general, like this is the area of the picture I'm talking about kind of things. What we're going to do next is we're going to use Venn diagrams basically to solve problems. Now, before I give you one that's actually a problem in written form, I want to show you how it works just with some numbers involved, okay? So this one doesn't have all the details out, so we're going to write in all the details that you would be given first on the problem. So the first thing I'm going to tell you is some numbers. So this is n of A is 24. N of B is 24. Just jot them down and I'll show you what we're going to do with them next. N of C is 26. N of A intersect B is 10. N of B intersect C is 8. And N of A intersect C is 15. Got two more. N of A intersect B intersect C. Do you recognize that one, Allie? There's that A intersect B intersect C. This one has the value 6. And then N of U is 50. So just jot them down for now, and then I'll show you what we do with them as we do our work. So you're doing a problem like this, this is how the problem starts. They give you all those numbers to start with, okay? You're not creating any of them or anything. They give those to you. All right, so as you're doing this, you're starting off. You have no reason to believe that the diagram doesn't overlap in 3 ways like we just did before. We're going to draw that then in that general way of overlapping. So we've got our diagram with 3 overlapping circles. And they have names A, B, and C. And we've got the universal set U. So far we've started out the same way we did before. We've drawn the same kind of a picture. Now what's going to happen is we're going to fill in numbers in each of these regions, but they aren't going to be just numbers that sort of indicate the region. You know, that's what we were doing before. We were using numbers sort of just to indicate spaces. What we're going to be doing now is we're going to be using numbers to indicate that's the number of items in that region. So for instance, the one we're going to start with, let me just tell you, is the number 6, and I'll explain that in a minute. But this number 6 is going to go in the dead center here, just like Allie asked about what would that would be, you know, called. We're going to put the 6. That means if these 3 things describe 3 different traits or categories, there are 6 items that would be put in all 3 of those categories. Okay, that's what this number means.
So combined, they're all 6.
Not combined, but they all include that feature. Right, so like if circle A is mothers and circle B is teachers and circle C is Nazarenes, because I'm a Nazarene, then I would be in this middle part. And so would you know, anybody else who classifies themselves in that way. Okay, so this is just the 6 people or 6 items that are in all 3 categories at the same time. Okay, so, and it'll make more sense when I do some problems with some language, but that's what that means. All right, so if you take a look, what we want to do is we want to fill in all 8 of those regions with numerical values. Okay, numerical values that indicate elements in those regions. But the problem is that we have to start in a specific place. For instance, if we start up here with the n of A equals to 24, there are 4 different areas of the graph that are the things in A. Well, what would I do? How would I decide how to break up the number 24? Well, right now, if that's all I have to go on, I'd have to use some kind of trial and error process. And there are a lot of options for breaking up the number 24 into 4 separate spaces. I don't want to do that. And you don't either. So anything on that first row of everything I wrote is not helpful at the moment because I'd have too many trial and errors. The second row is better. Let's look at A intersect B. Well, here's circle A, and here's circle B. And there's only 10 items there. But still, circle A and circle B overlap in both of these places, don't they? So again, starting with the number 10 means trial and error. I would have to do every combination to see actually which one worked. This is like Sudoku when you don't have enough, you know, pieces of information to fill things in, right? Or if you're trying to guess on a crossword puzzle, infinitely many things to choose from. It doesn't work very well. So I don't really want anything on the second row either because I have 2 regions everything on that second row is representing. The third row finally is helpful. It's helpful because I actually know the intersection of the 3 locations, and that is exactly 1 place. right? Very dead center. So that number 6 goes in the middle.
So we can go back to the
You got it. So now we're going to go back. So I'll just draw a line through them as I do them. So now we're going to go back exactly to the A intersect B, which is supposed to be 10 items. Well, A and B intersect in both of these regions. So I already have 6 of them in the lower part of that picture. So that part would have to be the number 4. So I'm going to put 4 in here because now the 4 plus the 6 are a total of 10. So I've filled in the information related to this piece right here. 10 items and those two combined. We're going to keep working along that second row because we can do the same thing. It says I have B intersect C. Well, B intersect C is right here. I already have 6 items in there and I'm supposed to have a total of 8. So I'm missing 2. So there's 2 that go right here. And then I've done this piece of information. The last one in the overlapping parts is A intersect C, which is down here. There's already 6 items there, and there's supposed to be 15. So how many am I missing? 9. Now what? Yeah, then I can go up to the top row, exactly. So going back up to the top row now, we can just work our way straight across that top row. N of A is 24. Well, previously we talked about the fact that that was unhelpful because I had 4 regions. But now I have 4 regions with 3 of them filled in, right? 3 of them filled in. Did you add them already together?
Yeah,
19? Does that look good? Okay. So if there's 19 and there's supposed to be 24, how many am I missing? 5. Thank you. Sorry, I didn't hear it. 5. So that one's done. Next one, circle B is supposed to have 24. How many are currently in it? 12. So how many am I missing? 12. And then I'm done with this piece of information. The last one, N of C, 26. How many is in there already? 17. So how many am I missing? 9? 17, 9, 26. Perfect. So that one's done.
Do we just put 50 on the outside?
It's a good question. So Kayla asked, N of U is 50. What are we going to do with the 50?
We're gonna add up all the numbers and make sure it's 50.
Yeah. So Tristan, this answers your question a little bit more fully too of do I need the rectangle? And the answer is yes, because the universal, at least on this picture, the way it's drawn, the universal set would include all the sets that I already have, plus this region on the outside. So somebody grab calculator, add up all the values inside or in your head if you want to, whatever. How many do we have total?
27.
What was it? 47. And I'm supposed to have 50, so how many am I missing? 3 is going to be on the outside, exactly.
Does it matter where in the rectangle that 3 is?
Nope, not at all. Okay, so this is how we process through putting the numbers in the places. Okay, that's how we think through it. I want to do a couple of examples now that actually have context of how this sort of description at the top would come about, given actual like word problems kind of thing. Okay, so we're going to do an example that's a pretty simple one to start with. Joe Long works on albums for musicians. Last year he worked on 12 projects, and then we have some details about those 12 projects. He wrote and produced 2. He wrote a total of 5. He produced a total of 7. So 2 circles. Very good, Skylar. That was my very first question, is how many different categories do we have? And we really have only 2 categories. What are those 2 categories, Skylar?
Road writing and producing.
Yeah, and so I will just, you can label them with what they represent. You can label them with letters. It doesn't matter. But you have to indicate clearly to me that you know what is which place. And then the universal set out here can still just be called U. And then we're going to fill in some details. The first one says he wrote and produced 2. What does that mean? Yeah, that's the part in the middle. Okay, the and. Remember that keyword and? What does and mean in terms of our set operations?
Union.
Intersection.
Just kidding.
Yeah, this is intersection. So the intersections that overlap. So this is the 2 that goes in the middle here. Now, the second line of information says he wrote a total of 5.
So 5 times 2 is
5 minus 2 is 3, so I'll have 3 on the outside.
Wait, why wouldn't you switch that?
Because we already took into account the
Oh,
2
got
for the
it.
2 he wrote and produced, right? You have to be very careful. The numbers they give you are not usually the numbers that go in the regions, at least not all of them, right? You have to think through the language being presented to know what numbers are going to go there. All right, the last part says he produced a total of 7. So 7 minus the 2 in the middle are 5 more for my 7. Am I done? Not quite. How do I find that outside region?
He worked on 12 total.
Mm-hmm. He worked on 12 total. So currently I'm missing how many? 2. So there are 2 on the outside. So he did something else on those projects apparently, right? Okay, so drawing your diagram is one part of this process. And I expect a diagram to be drawn on all of these. Answering questions A, B, and C is dependent upon the diagram you draw. So if you do make an error on the diagram you draw, I will be using your diagram to decide whether or not you can answer the questions according to your diagram. So you're not double whammied on making a mistake, okay? So we are going to use our diagram to answer the questions, and the questions are usually very easy to answer if you're looking at the diagram you created. So the first question says, how many projects did he write but not produce? That's 3. How many did he produce but not write? That's 5. And how many did he neither write nor produce?
2.
Exactly. That part's quick, right? Okay. One more example like this. And it's much longer in detail because why? Read through it.
34 years.
This is got 3 circles.
There's going to be 3 circles. How did you know there's going to be 3 circles, Skylar?
Jesus loves me, this little I read in the Bible, those are 3.
Yeah. It's talking about 3 different categories of things, right? In this case, songs that children would know or youth would know. So when I draw my diagram, I'm going to have 3 circles. And in my diagram, I'm going to label them much like what they're describing. So I'll label the first one, I'll shorten it and just write Jesus. The second one I'll write light. And I'll write the third one as Bible, Bible. And this is my universal set. All right, there's a lot of information here. And it's not always given in an order that is helpful to sort of bounce. I mean, sometimes you have to bounce around. So taking a look at the information that's given, which piece of information is where we want to start?
Jesus.
The last one. Yeah, the problem with starting at the beginning, remember, is like we did at the other one. If I start at the beginning with a 15 and I look at the Jesus circle, there's 4 places to put things. So on this one, it happens to be the one that's listed last, where it says 13 learned all 3. So where does that 13?
Why are we gonna start off in-
Michaela,
Sorry.
can you just raise your hand when you have questions so that I can stop talking? Thank you. All right, what would you like to ask?
Why would we have 13 and not? I hadn't learned all 3.
Why would we have that?
Yeah, why is that the first one?
Well, they tell us that as a piece of information, so it's one of the possibilities. Why would we like to start here? That's the piece of information where they all 3 overlap, and there's only one place for that to happen. Only one place where they all 3 overlap. So like when we're looking at our information, what we're trying to decide is which one gives us information about one specific region. And the ones that we most often see is one telling us something about the middle. It doesn't have to be done that way. I think you have an example in your homework where it's not quite like that. But you're looking for the piece of information that tells you about one specific location. So on this one, it's the 13 in the middle. So we're going to put 13 right here. Now I've already dealt with this one, so I'm going to draw a line through it. What do you want to deal with next? Yeah, we could do it just with the one right above it on this one. It says 14 had learned this little light of mine and Jesus loves me. So this little light of mine and Jesus loves me is this part of the picture, right? Those 2 in the middle, top middle. So this 13 and 1. So I need one more person, right? So I need a 1 right here. Can we just move our way up again? I think it'll work. It says 15 had learned this little light of mine in the BIBLE. So this little light of mine and the BIBLE is this piece over here. So I need 2 more out here. You can do this one more time. It says 13 had learned both Jesus loves me and the BIBLE. Yeah, we could put a 0 there. There's nothing wrong with that. Can't put negatives in there, right? But we can put a 0 in just fine. So we've got 0 right there. Shall we move our way up again? 28. It says 28 learned the BIBLE. So currently in that lower circle for BIBLE, how many do I have? 15. So how many am I missing? 13. So there's 13 down here. All right, next one says 18 had learned this little light of mine. So light of mine's on this side. How many do I have? 16, so I'm missing 2. So we've got 2 out here. The last one is 15, Jesus loves me, right in here. So I just need 1 more because I've already got 14 of them, right? Now what? I marked them all off.
Well, you have 34 youths, so you have to figure out what
Yeah. Is that what you're going to tell me, Mary?
Yes.
Yeah. It's okay. We've got a 34 over here that tells me something about how to figure out what goes on the outer part of my region. So right now, what do I use that 34 to do? What am I doing next? Yeah, we're going to add all the numbers we currently have in our diagram together. So we have all of these numbers. What do they add up to?
32.
32. So I'm missing 2 people. So there are going to be 2 people on the outside of my circles inside of the circle U. So I dealt with that piece of information. All right. Diagram complete. Now we're going to answer questions. First question. How many children had learned exactly 1 of the songs? Okay, so you're saying 16. How are you getting 16? Kayla, I'll let you answer because I heard you first.
One person, Jesus loves me, alone, and then 2 people know this little light, and then 13 people know the IBLE.
Okay, is everybody good with that? You see where she's getting her numbers from? Okay, good. So I'm going to write down the numbers. It's helpful when you're answering your questions because then I know where you're getting your numbers from, or at least I'm more likely to know if you actually write down the regions that you're adding together and then write the sum. So what did you say it was? 16?
Yes.
Right? Good. How about at least 2? Now this phrase is different. This says exactly 1, but the next one says at least 2. What does at least 2 mean? Okay, go ahead, Whitley. Minimum of 2, which means 2 or more. So it means they know 2 songs, or in this case, all 3. Okay? So which parts of my picture describe that? The middle?
And then the 3 surrounding.
Yeah, and so it's this sort of a, I don't know, boomerang kind of shape in the middle kind of thing going on or whatever. I've got the 1 at the top, I've got the 13 in the middle, the 0, and the 2. It happens to add up to the number 16, but not for the same reason as the last one, right? Okay. So I've got 1 plus 13 plus 0 plus 2, which again is 16.
If there is a 0, do we have to add?
You don't have to write down the plus 0, no. But I do want you to recognize that it was part of the picture I looked at. Sure. But none of these songs. 2. Not much to do on that one. And then how about this little light of mine, but none of the others?
2.
That's 2 on the outside of this little light of mine. Good job, guys. Make sense? Okay. Have one more example. 2 more examples, 1 more slide. Is the operation of Cartesian product, commutative? Why or why not? So Cartesian product, we'll go back to the slide that had that on there to reference it. Looked like this. When I have a Cartesian product, I get a list of ordered pairs. Okay? And so I have written down right in this problem already A cross B. And A cross B has these elements x1, x2, x3, y1, y2, y3. Okay. The question of commutativity means, can I switch the order of the the product being crossed? So right now it's A cross B. In other words, if I did B cross A, would I get the same list of elements? Would you? Let's take a look. So I already have this one done here. In fact,
Did you say the same number?
no, not the same number of elements, the same elements.
I didn't know you wouldn't.
Okay, so this was A cross B from the previous slide. And now we're going to do B cross A. What would B cross A look like? Okay, 1x, 2x, and 3x. And what else? 1y, 2y, and 3y. Are these the same elements that we got the other direction? No, they're not. A graph's a really good picture to think in your mind. So the question you should be asking yourself, or sort of trying to think through, is are these the same thing? Is x1 and 1x the same? Well, think about a graph, right? Just a two-dimensional xy graph. So if you're working with a graph like that, is the ordered pair 2, 1 the same as the ordered pair 1, 2? No, they're not the same. So the answer to this is going to be no, because the point xy, for instance, is not equal to the point yx in general. Obviously, if x and y are the same thing, it works, but that's not what we mean. We mean for any x and any y. Now that's different because all the other ones were commutative, right? You had the ability to switch the orders around. This one didn't. Last example. A student argues that adding two sets and taking the union of two sets is the same thing. How do you respond? What's addition used for? What do we add? Numbers. We don't add sets, right? We don't have a set addition property. So addition is simply not a property of sets. So addition is not a set operation, we'll say it that way. We add, we'll say it this way, we can add cardinalities of sets.
I feel like elements.
Cardinalities, you mean? No, cardinalities means the number of items in a set. So for instance, above, right here in the problem that we just listed, we have n of A, the number of items in set A is 2. The number of items in set B was 3. Right up here. So we can add the 2 and the 3, but we can't add set A and set B.
Yeah.
We can take unions, we can take intersections, but we can't add them.
You say the definition of cardinality?
Cardinality is just the number of items in a set. The number of items in that, whatever it is your description of you're talking about, number of items in the set. And that's actually what we were working with on those last 2 examples, 3 examples actually, is we were putting cardinalities inside of regions on that picture, right? Whereas the first time around when we were looking at shading, we were putting sort of just representative numbers and locations. All right.